Hello, I am Andrew and this is Stanley C. We will be discussing vector architecture and vector processors. This is our table of contents and agenda we will be discussing today. First is vector processor and SIMD processing, basic vector architecture, memory banking, vector performance, and then RISC-V vector extension, advantages and disadvantages of vector processor, and the limitations of vector processor.
So when we're talking about vector processor in SIMD processing, first we need to define what is SIMD. So SIMD, or single instruction multiple data processing, is a single instruction that can operate on multiple data elements. This was divided into what we call array processor and vector processor. Array processor operates on multiple data elements at the same time using different spaces, while vector processor, which operates on multiple data elements in consecutive time steps, but still use the same space or same functional units. Looking at a simple pseudocode below, the first line simply loads data from memory address A into a vector register that can store three elements. The next line adds 1 to each of the element, and the next line multiples each element by 2, and the last line stores back and or updates the value in the memory with the ones in the vector register. So to simulate the difference between array processor and vector processor, let's say in the array processor we have three processing elements that can do any operations, and in vector processor we have four processing elements that can do load, add, multiply, and store. So in array processor, each operation executes in parallel at the same time. Meanwhile, in vector processor, in the first cycle we load the first element, in the next cycle we load the second element and perform addition on the first element, and so on until we finally store the third element back in the memory. So the way it works kind of like a pipeline. So to summarize this, in a reprocessor we have executed same operators at the same time and different operators in the same space. While in vector processor, we are executing operation, different different operation at the same time and same operators at the same space. Now, this makes vector processor more hardware efficient compared to array processor, as you have one dedicated processing element for each of the functionality for each of the functionality, while in array processor, each processing unit needs to be like a general purpose register or should be able to do everything. So when we're talking about vector processor, we need to define first the meaning of a vector. So a vector is simply a one-dimensional array of numbers. So when we say a vector processor, means it's a processor where one instruction operates on a vector instead of just one element like what we usually did in the scalar processor. So when we're talking about basic vector architecture, the following should exist in the vector architecture. The first one is a set of vector registers, which is a fixed length bank to hold a single vector. We also need a vector functional unit, which is a fully pipelined unit that can start a new operation on every clock cycle. We also need a vector load store unit that can load and store vectors to and from the memory. And we also need a set of scalar registers to be used for any scalar computation. This could, one example for this would be when we want to compute for the memory address to be passed to the vector load store unit to be used. So each vector register holds an n times m bit values, where n represents the row and m represents the columns. So there's there's a register that we call a vector length register, and which is used to operate vectors on different length, where the maximum value of this vector length register is the capacity of the vector register itself. So and there's also the vector stripe registers, which is used to identify vectors where its elements are stored apart from each other in the memory. And the word stripe here means a distance between consecutive elements in the memory. Lastly, we have the vector mask registers. This register indicates which elements of the vector to operate on, and it's what you may what you may guess. It's used usually in the conditional operations. So let's say I want to do a vector add, and I don't want to add it on all of the elements. I can use vector mask to indicate which element do I want this vector add to operate on. So in relation to the vector stripe registers, how exactly is our data stored in the memory using vector processor? So let's say we have a 4 by 4 matrix. How is this matrix data stored in the memory? So a matrix can be viewed in a row major or column major. When we say a row major, this means all elements in a single row are stored in a consecutive memory location. While if we are talking about column major, this means all elements in a single column are stored in a consecutive memory location. And this is where the stride from the previous slide became very useful. So let's take an example for this row major. In the row major, the way we traverse is usually 0, 1, 2, 3, 1, 2, 3, 0, 1, 2, 3 until the last element in the matrix. So let's say we want to load the entire row, then we want to load an entire row, then the stride in here will be 1 because the distance between consecutive elements is just 1. However, if it's a row major matrix and then we want to load an entire column, then the strides in here will be 4 because the distance between the consecutive elements in here is 4. And in one case we might need to load the rows only, but in other case we might need to load the columns only. And yes, this is where vectors, right, registers become very useful.